Hello, welcome to yet another episode where we shall be looking at the proposed memorandum of the Mathematics Paper 1, the May-June examination. Okay, so the memo is not yet out, but we shall see this as our proposed memorandum. So together with me, let's see what is going to happen. So this paper had 11 questions. Okay, and then we have some special answer book that was provided for the first time. You need to clearly show the calculations, diagrams, in determining the answers, because answers only will not be given full marks. Diagrams not necessarily drawn to scale, and all of that. Okay. So what we see with the 11 questions. Okay, so let's look at question number 1. They are telling us to solve for x. So with this one, we have x squared minus 3x minus 10 is equivalent to 0. So what we're going to do, we can get our factors and say that if we have x minus 5 into x plus 2 is equivalent to 0. So if we are to solve this, it simply means that our x is going to be 5, or basically x is going to be a negative 2. So those are sweet 3 marks. And then 1.1.2, telling us we have 3x squared plus 6x plus 1 is equal to 0, correct 2 decimal places. So this one simply means we're going to have to use the quadratic formula. So I'll put it this side. So 3x squared, okay, 3x squared, let's see, okay, plus 6x plus 1 is a 0. So we know that our A is a 3, our B is a 6, and then our C is a 1. So from the quadratic formula, that is negative B plus minus square root of B squared minus 4AC all over 2A. When we substitute, we're going to have a negative 6 plus minus the square root of 6 squared minus 4 into 3 times 1. Everything is over 2 into 3. Okay, so when I punch this into my calculator, the first value of x that I'm getting is negative 1,82. The other x value is going to be negative 0,182. So those are the answers that we have for 1.1.2. And then 1.1.3, we have 2 to the x plus 4 plus 2 to the x is equal to 8704. So what we're going to do here, we need to factorize out the 2 to the x, so that we have something like 2 to the x into, we shall have 2 to the 4 plus a 1. This must give us 8704. And then I'll be left with 2 to the x. We know that 2 to the 4 is the same as 16 plus 1, making it 17. Then I'll divide both sides by 17. So let me just erase this. Okay. Okay. For the purpose of everyone knowing how we're moving, so we're going to have 8704. And then we say 2 to the x. When I divide both sides by 17, I'm going to end up with 512. And then I have to express 512 as a base of 2. So it is 2 to the x is equivalent to 2 to the exponent of 15. The bases are the same, meaning that our x is going to be a 15. Okay. Then 1.1.4, x minus 8, x plus 2 is less or equal to 0. So in this case, we know that our critical values, okay, critical values are going to be negative 2 as well as a positive 8. Then how do we represent this? Now, since the A is going to be positive and then the inequality is less, meaning that we're going to have an answer, a solution set of negative 2 is less or equal to x, less or equal to 8. This should be the solution being represented in that format. Okay. Alternatively, people can use the parabola, draw your parabola. You have your -8, you have your +2, and then you shade off the required region, okay? Then 1.1.5, we have x plus 3, let's jot it aside. So we're saying x plus 3 square root of x plus 2. And then this should be equivalent to a 2. So step number 1, we need to isolate this x to that side, okay? So I'll be left with just a 3 square root of x plus 2 is equivalent to 2 minus x. And then I need to square both sides, which is my next step, so that I can kill the root sign. So this square will affect the 3. So 3 squared is going to be a 9 into the root sign falls away. We have x plus 2 is equivalent to, when I open this, because it is a 2 minus x, and then a 2 minus x. Okay, so that's going to be a 4 minus 4x plus x squared. Let me open this side. 9x plus 18 is equivalent to 4 minus 4x plus x squared. Then I'll transpose and create a standard equation. So I'll have x squared. I move the 5 that side. I'm going to have minus 13x. When I move the 18 that side, I'll end up with a negative 14 is equivalent to 0. Then when I try to simplify this using vectors, you can even use the quadratic formula and end up with the answer. So I will say x minus 14, and then probably x plus 1 should be 0, meaning that our solutions will be x being a 14 or x being a negative 1. Now the last step is for us to test these answers of ours using the first original equation that we're given. So the original equation was x plus 3 root of x plus 2 must give us a 2. Okay, so we test the left-hand side against the right-hand side, left and right, and then see. So if I use 14, I know that 14 plus 2 is going to be 16. Square root of 16 is going to be 4. 4 times 3, that is already 12. And then 12 plus 14, that's like a 28. And on my right-hand side, I only have a 2. So I'll cross this out and tell us that it's not a solution. Okay. When I try with -1, I know that -1 plus 2 is going to be a 1. Square root of 1 is 1. 1 times 3 is 3. And then 3, we are adding a -1, which gives us a 2, which is the same value as the right-hand side. Therefore, our answer is a -1 for this question. Okay, so that is 1.1.5. All right, 1.2. 1.2, they're telling us that a rectangle that is having sides y minus 3 meters and x plus 2 meters has a perimeter of 24 meters and then an area of 32 square meters. Can we calculate the values of x and y? Now, this is a question to do with simultaneous equation. I don't know why these examiners have decided to twist it in this format. Okay, so we know that in a rectangle, the perimeter is given as twice length plus twice breadth, or some people call it the width, okay? Let's substitute. So this is going to be 24 is equivalent to twice. I'll say my length is y minus 3 plus my breadth, I'll call it x plus 3. And let's open it up. So 24 is equivalent to y minus 6 plus 2x plus 4. Let's simplify this, and this is going to give us a -2. When I move it that side, I'll have 26 here. So 2y plus 2x. Divide through by 2, meaning that x plus y should be a 13. Let me make x the subject here. Let me say that x is going to be a 13 minus y. I'll call this equation number 1. And then let's go to the area. So we know that area of a rectangle is given as length times the breadth. So y minus 3 into x plus 2 should give us a 32. we can substitute where there is x, we put 13 minus y. So y minus 3 into a 13 minus y plus 2 should give us a 32. So y minus 3 into, that's going to be now 15 minus y, should give us a 32. We open this up. So we shall have a 15y, and then minus y squared. I'm just opening up using the FOIL. Then this 3 and that is going to be a negative 45. It's negative 3 and that I'll have a positive 3y is equal to 32. Is that correct? Yes, seems correct. Okay, so let's create a standard equation. So I know that this 15 and the 3 will give me 18. Okay, let me move everything that side. So y squared minus 18y. And then when I move this 45 to that side, we know that 45 and 32 is going to give us 77 is equal to 0. So two numbers, if I'm to use factors, two numbers, we multiply to give us 77. You plus them, you get negative 18. That's going to be negative 7, negative 11 is equal to 0. Meaning that our y is going to be a 7, or our y is going to be 11. And if that is true, then we need to substitute these values back into that equation, okay? Meaning that our x is going to be 13 minus 7, which is a 6. Okay, so x is a 6. Alternatively, 13 minus 11, which is a beautiful 2. So that is how, is it a, yeah, it's a 2. So that is how this question would have been answered without any issues or without any hassles. All right, then question number 2. They are telling us that given the arithmetic series 5, 7, 9, up until 93, they want us to determine the general term. So since it's arithmetic, we know that Tn is given as a plus n minus 1 into d. Okay, so our a is a 5. So meaning it's going to be 5, but we know that the common difference is 2. So 5 plus, we have n minus 1 into 2. Then we open this and simplify it because they want it in this format. So that's going to be 5 plus 2n minus 2. Is that correct? Yes. And then we simplify that, meaning that our Tn is 5n. How is it a 5n? It's a 2n, man. So 2n plus 3. Okay, so that is what the question is asking for. Then 2.1.2, they're telling us the given series represents the number of kilometers that the athlete ran each week. So in week 1, the athlete ran 5 kilometers. In the second week, the athlete ran 7 kilometers up until the last week where the athlete ran 93 kilometers. So they are preparing for the ultra marathon. And then the athlete ran 93 kilometers within the last week. Okay. How long in weeks was the training program? So we need to look for the value of n if the Tn, if the last term is 93. So we shall say that 93 is equivalent to n plus 3. Let's move this 3 to that side. It's going to be a 90 is equal to n. Then divide both sides by 2, meaning that n is 45 weeks. So this person ran for 45 weeks or practiced for 45 weeks. And then 2.1.3, the athlete used this opportunity to raise funds for the high school. And then the community sponsored her with 10 rand for each kilometer this person ran during the training program. I get the total amount. So when they ask for the total amount, then we're looking at the sum of all these kilometers together. Okay, so you're gonna use the sum of an arithmetic. So there are two ways to this. Since I already have my last term as 45, I could use that approach. Okay, meaning that my Sn is gonna be n over 2 into a plus l, where l represents the last term. Okay, So what I'll do here, I'll say we have 45 weeks. That is correct. So it's going to be 45 over 2 into our first week was 5 kilometers. Okay. Plus the last week, which was 93. And then when I punch this into the calculator, I'm getting 2,205 kilometers. Okay. But then for each kilometer, this person got 10 runs. So we multiply this by 10. And then we get 22050 runs. So this is what this person raised. Okay. So we can use this, or we can also use that n over 2 into 2a plus n minus 1 into d. There's no problem. You should be able to get to the same answer. All right. Then 2.2, they're telling us that the general term of a geometric sequence is given as 2 to the exponent of n plus 2. Okay. Write down the first term. So T1, we just replace n with a 1. So 1 plus 2 is the same as 2 to the 3, which gives us what? 8. Then they want us to get the common ratio. So let's get T2 first. T2, which is going to be 2 to the exponent of 2 plus 2, which gives us a 16. And we know that our common ratio must be T2 over T1. So 16 divided by 8, which means the common ratio is just a 2. Okay, so that is one way of doing it. The other way is just simplifying that into the format of a r to the n, and then you get your ratio. Since they told us it's already a geometric. Then they want us to calculate the 20th term as a power of 4. So what is a power of 4? Meaning that the base must be a 4 with a certain exponent that we need. So let's substitute n with 20. So meaning 2p20 is going to be 2 to the 20 plus 2, which means 2 to the exponent of 22. When you simplify that, 2 to the exponent of 22, what we get? We get very big number. I'm having 4194304. Okay. Now, how do I express this as a power of 4? Okay, so I can use logs to do that. Okay, whereby, let me just erase this and show people. Okay, so we're saying we have something like 4 to the exponent that we don't know should give us this answer, which is 4194304. Okay, so if you use your logs, it should be, let me just check this out. So 4194304. Okay, so I can use that log formula that says log, I'll put the base of 4, and then I'll put this number here from the calculator, and then I'm getting 11, meaning that this should be written as 4 to the exponent of 11. Okay. Then 2.2.3, calculate the sum to infinity of 1 over Tn and so on and so forth. So we know that the formula for sum to infinity is given as a over 1 minus r. So let's try to get the terms of this pattern. Okay, so they said 1 over Tn. So if n is 1, the first term we got was 8, meaning that this pattern will be 1 over 8. The second term is going to be 1 over 16. And so on and so forth. So if we are to use this 1 over 8, 1 over 16 to establish the common ratio of this pattern, we're going to have our common ratio as a 2. Okay, so if the common ratio is 2, the sum to infinity said it's a over 1 minus r. Now our first term for this summation is 1 over 8. Okay, I'm dividing it by 1 minus, we say the common ratio is a half. Meaning that we have 1 over 8 divided by a half, and then the answer we get is a quarter, or 0.25. So that's what I'm getting in this case. Then 2.2.4, consider the first 21 terms of the sequence, okay, of the geometric sequence. Calculate the sum of terms in the sequence that are not powers of 4. Interesting. Okay, let me write it this side. So it's saying we have the Tn being 2 to the exponent of n plus 2. So we saw that the first term was 8. The second term was a 16. The third term is supposed to be a 32. And then the fourth term, which is supposed to be a 64. Okay. So let me just base on just these ones. So I know that 8 cannot be expressed as a power of 4. Okay. But 16 can, because that will be 4 squared. This 64 can, which is 4 cubed, and so on and so forth, up until to the 21st term. So if I look at 16 as our first power of 4, okay, because this is going to be the first power, the question is asking for the sum of that are not. Okay, let's focus on the not. So which means our first term is 8, and then 32, and then we're going to have the next one. Okay, someone asked down, what is the next one after 64? So that is 6. What is 2 to the 6? No, that is 64. And then to the 7 is going to be 128, meaning that we are just multiplying by 4. Multiplying by 4. Simply meaning that the common ratio there is a 4. And then our first term is 8. Okay, so let's get the sum. But then how many terms are they? Now, since they are 21, and whatever we are interested in is the first, meaning that we're going to have 11 terms overall. Okay, these ones that are powers of 4 are going to be 10. Okay, so let's get the sum of a geometric. So sum of the first 11, so a into r to the n minus 1 over r minus 1. Let's substitute that. Our a is 8 into the common ratio, which is 4 to the 11 minus 1 over 4 minus 1. Okay, so when I punch this into my calculator, 4 to the 11, we said minus 1. We close that. And then over 3. It's a very big number. So 11184.808. So that's the sum that I'm getting. Okay. That is the sum that I'm getting that are not powers of 4. Alternatively, somebody would have obtained the sum of the first 21, and then somebody could have also gotten the sum of the 10 terms that are powers of 4, and then you subtract the 2. I believe we should be able to go back the same answer. All right, then question number 3. They are telling us that given the quadratic sequence, okay, can we show that the general term is given as this? So these are free marks, no? For as long as they give you the general term, then we should be able to prove it. So this is going to be -5. This is going to be a -3. This is going to be a -1. This is going to be a +2 and a +2. So this +2 must be equated to the 2a. So we shall say that 2a is 2, meaning that a is 1, okay, which corresponds. And then our 3a plus b should be equated to the -5. And so 3a plus b is -5. But then if our a is 1, we move it that side, meaning that the b is going to be a -8. So if b is -8, then we know that a plus b plus c must be equivalent to the first term, which is 14. Now our a is a 1, our b is a -8, plus c should give us 14. So this is going to be a -7. You move it that side, you get our a as a 21. Sorry, our c as a 21. So it's all about showing how you obtain the a, the b, as well as the c. Then you draw the conclusion that therefore our Tn is n squared minus 8n plus 21. Okay, Then 3.2, they're telling us that two consecutive terms within the quadratic have a difference of 33. Calculate the value of the larger term. So this difference, we need to find its position, because we know that this 5 is the first difference. The first term of the first difference is between term 1 and term 2. Then this second difference between term 2 and term 3. So if this continues, there's going to be a 33 somewhere there. Let's find its position, and then we look for what the question is asking for. So the first thing to do is find the general term of the first differences. Okay, so meaning it's going to be 2n minus 7. Okay, because this is the arithmetic. If you simplify it, first term is that the common difference is that. So it's 2n minus 7. And then I'm going to equate this to a 33. Then I'll move the 7 that side. Then my 2n will be equivalent to a 40. Okay, let's just erase this. We're saying that the 2n, okay, should be equivalent to a 40. Divide both sides by 2, meaning that n is going to be 20. So the position that this one is in is the 20th position, meaning that it's going to be between T20 and then T21, because 1 is between 1 and 2. 2 is between 2 and 3, meaning that T20 is between 20 and 21. So the bigger one is going to be T21. So let's look for T21 from the general rule, which was n squared. Okay, so it's going to be 21 squared minus 8n. So 8 times 21. And then plus, we're saying a 21. That's correct. Okay, so when we punch this into our calculator, so 21 squared minus 8 times 21 plus 21, I'm getting 294. So this is what I end up with. Okay, then question 3.3, they're telling us that the value of m is added to each term in the quadratic sequence, such that the values of m for which the terms between T1 and T7 of the quadratic will have negative values. Okay, so the question is, how do we now approach a question like this? Okay, so number one, if our focus is on T1, okay, we know that the T1 is what? Is a 14. So if we get the Tn, which is a positive n squared minus 8n plus 21, if we substitute n with a 1, and then they are telling us we are plusing m, okay? Substitute t as a 1, which means we're going to end up with something like a 14 plus m. And then at the point where we have 7, t as a 7, so 1, 2, 3, 4, I don't know, let's substitute there and we get 7. And then we plus your m. Okay, so the same thing, and then we focus on t is equal to 7. So that's going to be 7 squared minus 8 times 7, and then plus 21, which gives me also a 14 as well, okay, which is good. But then we know that our constant term is just a 21, which is the C value. So if the C value is 21, it simply tells me that my m is going to be a value between the 14 as well as the 21. Okay, 14 being that we got it from the first term, okay, and then 21 being that is the constant term. So I'll come down and say that 14 must be less or equal to m, less or equal to 21. So that's how I would have obtained that. Then question number 4, which is the functions, is being told that the graph of f of x, which is 4 over x minus 3 plus 4, is drawn. M is the point where the asymptotes intersect. C and D are the x and the y intercepts respectively. And A is a point on f such that M is the closest point. So the closest point must always be passing through the axis of symmetry. Okay, so this question is not asking for the equations asymptotes as they always do, but they just want us to get the coordinates here. So from here, this is going to be a 3, and then that is a 4, which means that M is going to be 3, and then 4. Then 4.2, they want us to get the coordinates of D. So where is D? D is the y-intercept, and the graph of F is passing there. So for y-intercept, X is a 0. So it's going to be 4 over 0 minus 3 plus 4. So punching this into our calculator, I'm ending up with 8 over 3. So they want the coordinates, so it's 0 and then 8 over 3. Okay. And then 4.3. If y is equal to x plus t is the equation of the line of axis of symmetry of F, calculate the value of t. So our gradient is positive. So whenever we look for axis of symmetry, we must use the intersection of the asymptotes. Okay, so where there is y, I'll put a 4. Where there is x, I'll replace with a 3, meaning that 4 is equal to 3 plus t. Substitute that or move, transpose that, meaning that our t is going to be a 1. Then determine the values of x for which f of x is less or equal to 0. F of x is less or equal to 0. So where do we find the graph to be below 0? Determine the values of x. Okay, so the trick here is very simple because we can only see that from point C, that's when the graph is below 0. Okay, meaning that we need to get the coordinates of C between this asymptote and the C value. That's when the graph is just below. And so we're going to say that at the x-axis, okay, y is going to be 0. Then replace y with a 0, meaning that 0 is going to be 4 over x minus 3 plus 4. Let's transpose the 4 that side. So negative 4 is equal to 4 over x minus 3. Cross multiply. So negative 4 into x minus 3 to give us a 4. Open this up. Why don't we just divide by negative 4? So that we know that our x minus 3 is equal to negative 1. And then the x becomes a 2. So meaning that this is a 4. Now, to answer the question, they want the value of x for which the graph is less or equal. Meaning that I'll say that all values between 2 and 3. So 2 is less or equal to x and less than 3. So there shouldn't be an equal sign here because the 3 is an asymptote. So this region is what they are interested in. All right, so that is that. Then 4.5, they want the coordinates of A. What is A? Where is A? So they told us A is the point that is closest to M. So if we have our axis of symmetry that is moving this sort of direction, okay, this axis of symmetry must pass through the closest point. Okay, so how many maxes is 3 maximum. So at this point, the two graphs are equal, so we're gonna solve them simultaneously. So I'll say that let me put this side, that y is equal to x plus 1, and then that one was is it 4 over x minus 3 plus 4. Is that true? 4 over x minus 3 plus 4. Yes, perfect. Then I'm going to equate the 2. So 4 over x minus 3 plus 4 should be equivalent to x plus 1. Let's move this to that side. So 4 over x minus 3 is equivalent to x minus 3. Then cross multiply. 4 should be equivalent to x minus 3 squared. Open it up and let's solve for x. So that's going to be x squared minus 6x plus 9. Remove the 4 that side to give us a 0. Meaning that x squared minus 6x plus 5 should be 0. Getting the factors of this, we're going to have x minus 5 and x minus 1 is equal to 0, meaning that x is either a 5 or x should be a 1. So we're seeing that the graph, the line is meeting there or meeting here. So at this point, that is the one of interest. And then our A should be the 5. Now for us to get the y coordinate, let's use the axis of symmetry, meaning that y should be a 6. Therefore, A is going to be 5 and 6. All right. So that's how we get those three marks. Then a single transformation is applied to F to obtain a new graph as shown below. Okay. So we have this H, the new graph, and then A prime is the image of A under this transformation. We need to calculate the length of A and A prime. So when you look at these two graphs, this is a 4 over x minus 3 plus 4. This is the original. But now this is what we are obtaining afterwards. Then the question is going to be, what happened? Remember, it is a single transformation that took place. So when I look at it nicely, I feel like it's just a reflection about the y-axis. Is that true? Yes, it's a reflection about the y-axis. And since it was reflected, whatever was x must change the sign. That's why this got to a negative, okay? And then if we have this also changing, which means the quadrants also change positions. So the horizontal simplicity is not going to be affected. What's going to be affected is this vertical, which means it's going to be somewhere here around the negative 3 point, okay? And then this arm of the graph is going to be somewhere here, okay? And then this arm of the graph will be somewhere here. Now, if that is true, this point A is going to be somewhere after negative 3, which means it's going to be at a negative 5, together with its y coordinate, which does not change. So this was a 5 and a 6, meaning that we have 5 units to the y and then 5 units away from y. So this total must give us something like just 10 units. The question just wanted to get length. Okay, so that is how I would have approached 4.6. Then question number 5, they're telling us that the graph of f of x, which is a into x plus b squared plus q. Now this is a parabola with a turning point, okay? Is drawn. C is given as that, which is the turning point, and then there's a point B. Then 5.1, can we show that the graph can be written as this? Okay. So since this is the turning point approach, we know that it's going to be this one flipped around. And then Q will represent the 4. Then for us to get the A, we can use the point B. Okay, so I'll say y or f of x is equal to A, okay, into x plus 1 squared, and then plus 4. Let me substitute x and y with this point of B. So negative 4 is equal to A into negative 3 plus 1 squared plus 4. When I move this 4 to that side, I'll have a negative 8. And I simplify this, I'll end up with a 4a, meaning that our a is going to be negative 2, which is that. Then let's replace this negative 2 back in the equation and we open it. So negative 2 into, when I open this bracket, I'll have x squared plus 2x plus 1. And then I have a plus 4. Let me open the bracket using 2. So it's negative 2x squared minus 4x minus 2 plus 4. So negative 2x squared minus 4x plus 2. I think that's what the question gave us. Okay. And then 5.2, can you determine the values of k for which h of x is equal to f of x plus k will have no real roots? So this is going to be like, is it more like a difference? So, no, not a difference, but it's more like and the nature of roots. Okay. So what I'll do here, it's a 2-mark question. It's a 2-mark question, meaning that we just need to shift this graph downwards, 4 units downwards. So for as long as k is less than -4, then we shall be good to go. Alternatively, you can go the long approach and say that minus 2x squared minus 4x plus 2, saying we are plusing a k. For it not to have real roots, which means the determinant must be less than 0. So b squared minus 4ac is less than 0. So our b is -4. We square that, minus 4, our a is -2. And then our c is going to be the whole of this, which is 2 plus k, should be less than 0. So 16, that's going to be a plus 8 into 2 plus k is less than 0. So 16 plus 8k should be less than 0. This is a 32. And move it that side, which means 8k is less than -32 divided by 8, meaning that k should be less than -4. So that is how we would have also gone about it, okay? Then 5.3. 5.3. They are telling us that the graph of y is equal to g prime of x, where g prime is the derivative of g. Okay? And this g is obtained when f is reflected over the line y is equal to 4. And draw a sketch graph of g if g of 0 will be negative. Clearly indicate all the stationary points. So this is more like a cubic function that we need to obtain, okay? So if I look at this, the question is going to be, what did we differentiate? Because we have this f, and we need the derivative. No, it's a reflection. Okay, so if we reflect this upwards, meaning that instead of us having a -2, we're going to end up with a positive. So if this is a 2, if it's flipped upwards, it's going to be somewhere here around the 4. It's going to be around the 4. Okay. Because this is the line where the reflection must take place. Okay. So they talked about the derivative of g is obtained when f is reflected over. So reflecting it over, remember we're saying we're getting a positive 2x squared. Let me just use this. The positive 2x squared minus 4x plus 4, something like that. So if that is true, then we need to find more or less whatever we differentiated to give us this. Okay, so that could be something like 2 over 3x cubed. You could have a 2x squared. Okay, you could have a 4x. Okay, and then we can have some sort of a constant. Now, since they told us that when x is 0, the value that we have is going to be a negative, and our a here is kind of positive, meaning that the shape of our graph should be something like that. Okay, something like that. When x is 0, I don't know, let's just, this is your y, that's your x. X is 0, the y is negative, less than 0. So I think something of the sort would make some sort of sense. But what we need to know is that that is going to be, what do you call it? It's going to be a cubic function in any case. Question number 6, okay. The graphs f of x is equal to p to the x plus q and g of x is mx plus c are drawn. A is 3, 4, the point of intersection of f and g. We have p, which is 0, -3 is the y-intercept of f, and then is the x-intercept. Okay, calculate the values of P and Q. So we know that Q is the asymptote. So let's use this point, which is 0 and -3. So if our y is -3, that is 0 to something like that. Anything to the exponent of 0 will always be a 1. Okay, move the 1 that side, meaning that Q is going to be -4. When Q is -4, we need to look for P now using the 3 and 4. Okay, so what we're going to say, we're going to say where there is y, we put a 4. Where there is x, we're going to put a 3, then -4. Let's move this to that side. We're going to have 8 is equal to P cubed. Let's express 8 with an exponent of 3, which is going to be 2 cubed is equal to P cubed, meaning that our P is going to be a 2. All right, so P is 2, and then Q is basically a -4, not a 3. It's a -4. Okay, then they want the range of F. So range, we're basically looking at the y values. So y must be greater than the asymptote. Okay, it's above. Then the graph of the inverse of G also passes through B. So if the inverse is passing through B, determine the equation of G. Okay, so let's get this straight. If 0 and -3 is for the inverse, meaning that the original graph must be a -3 and 0. Okay, and then G is also passing through 3 and 4. So let's get the equation, which will be mx plus m is the gradient, which is changing y over changing x. So I'll say 4 minus 0 over 3 minus 3. So that is a 4 over 6, which is a 2 over, something like a 2 over 3. Then with the equation of a line, we know that y minus y1 is equal to m into x minus x1. I'll use the -3 and 0 as a point of choice. So that's going to be y minus 0 is equal to 2 over 3 into x minus -3. If we simplify this further, we shall have a 2 over 3x. That's going to be a positive 2. Okay, so that is what I'm ending up with, okay, with that regard. Then 6.4, they want us to get the inverse. So with the inverse, let's switch this around. Where there is y, we put x, and then where there is x, we put y. So we move this to that side, so it's going to be x minus 2 is equal to 2 over 3y. And multiply through by 3. It's going to be 3x minus 6 is equal to y. Divide through by 2. So y is going to be 3 over 2x minus a 3. All right, so that is what we end up with question number 6. Then question number 7, finance. Telling us that Mr. John invests an amount of money in an account that pays an interest at a rate of 15% per annum compounded monthly. So I play the effective rate. It's been a while since they asked this question. So we shall say 1 plus the I effective is equivalent to 1 plus I nominal over m to the exponent of n. Okay. So since they want the effective rate, we're going to have 1 plus the nominal rate is 15%, but we're compounding it monthly to the exponent of 12 minus 1. The answer that I'll get here, I'll have to multiply it by 100 straight away. Okay, so when I punch this into the calculator, I will get 16.08%. Then 7.2, they are telling me that Tino invests 500,000 into an account that is earning interest at a rate of 6% per annum compounded quarterly. Then Tino decides to withdraw an amount of 11,250 at the end of every 3 months. So that is quarterly. And he will continue doing that with these regular withdrawals until there is no more money within the account. Okay. So the question is, how many withdrawals of this much will this person be able to make? Okay, so we have two scenarios here. There is an investment of this much, and then we have the withdrawals, the present value approach. Okay. So let's go this side, meaning that the amount that we're looking at, which is the 500,000. Okay. Okay, will be equivalent. I'll use that formula of the present value, which is x into 1 minus 1 plus I to the exponent of negative n over I. So it's saying that our 500,000 is equivalent to 11250, 1 minus 1 plus our interest was 6% quarterly. This is going to be negative 4n, because we're looking for, what is the question asking for? Determine the number of withdrawals. So why am I multiplying by n? So let me just leave it as negative n, because now it will be a 4 times the n itself. So let's just leave it as a negative n. And this is over 6% over 4. So I'll start by multiplying both sides, or dividing both sides. So it's going to be 500,000 over 11,250 times 6% over 4 should be equivalent to 1 minus 1 plus 6% over 4 with exponent of negative n. Okay, so on my left, let's see, that's 500,000 times 6% over 4. And then this is over 11,250. Okay, let's have a fraction which is 2 over 3. Is equivalent to 1 minus. We have 1 plus. Why can't I just simplify this entire bracket once so that we save time? So 1 plus, saying 1 plus 6% over 4, which is 1,015. Okay, to the exponent of negative n. Okay, let me move this 2 over 3, sorry, the 1 to that side. So 2 over 3, we know that when we subtract 1, we're going to get negative a third. We have a negative 1,015, the exponent of negative n. So both sides, the negatives will become positives, okay? Then we can use our logs. So log 1 over 3 is equivalent to negative n. Log 1,015. Let's divide both sides by this log 1,015. It's log 1,015. So this cancels that, meaning that my negative n, let me simplify this first, okay? So it's saying log of 1 over 3, okay, over log 1,015. Okay, this is giving me negative 73,789. Okay, when I divide both sides by a negative, meaning that n we have negative 3, no, it's positive 3,79, which is approximately 73 withdrawals. Okay, that's how much this person is going to be able to get. So that's how I would have approached that question. Then 7.3, on the 1st of March 2021, AB made a once-off deposit of 12,000 into an account that is earning interest rate of 9.5 compounded monthly. Then she goes on to deposit 500 rands, the same account, on the 1st of April 2023, and continues to make such monthly payments. Okay, thereafter. calculate how much money was in the account immediately after the deposit 500 was made, 1st of March, exactly 4 years. Okay. So we have two scenarios. There was a lump sum, okay, and then we have these monthly deposits. So I'll divide this into two. So when I look at the lump sum, okay, I'll say the accumulated value is going to be the 12,000 into 1 plus. We know the interest rate is 9.5 monthly, okay? So 9.5% over 12 to the exponent of 12 times 4. So this money grows for the full 4 years. Okay. So 12,000, when I punch that in the calculator, I'm getting 17,521,18. Please just confirm with me if that's what you guys kind of have. Okay, let me just double check here. Okay, we say to the exponent that will be 48. 17521,18. Yeah. Okay, that is one. Then two, so for the deposits of 500 that were made, we're gonna have the future value formula, which is the 500 into 1 plus, that's gonna be 9.5 monthly to the exponent of 12 times 4. Wait a minute, why am I saying 4? Remember, it was 2023. Now this is 2025, so those are 2 years. It can't be 4 years. So this is times 2, okay? Minus 1 over our 9.5% over 12. Okay, substitute that into the formula. 500 into 1 plus 9.5%. We say percent over. This is 12, né? To the exponent of say 24. And then we subtract 1 divided by 9.5% over 12. So this gives me 13158.65. Is that correct? Does that even make some sense there? So we're saying 500 into 1 plus 9.5 over that to the exponent of 24 minus 1 over that. So I'm getting 13,000, guys, for the 2 years. For the 2 years, let's see. Okay, then I'm going to plus these two amounts together. Then I get the answer they want. So 13,158.65 plus 17,521.18. What do we get? So 13158.65 plus 17521.18. So I'm getting 30676.83. So that's what I have. I don't know. If you have anything different, please just help us. Then 8.1, they want us to derive this from first principles. Okay, so we know that the formula for first principles tells us that the limit as h tends to 0, f of x plus h minus the f of x over h. But we're told that f of x is just x squared plus 2. That's correct, no? No, minus 2. This is a minus 2. So meaning that my f of x plus h is going to be x plus h squared minus 2. Let's do the substitution. And so the limit as h tends to 0, I'm going to have x plus h squared minus 2 minus the entire f of x, which is x squared minus 2 over h. Let's open the brackets. Limit as h tends to 0. It's x squared plus 2xh plus h squared minus 2 minus x squared plus 2 over h. I'm opening with a negative sign. So this cancels that. Oops. This and that. Okay. Because we're saying this one, that 2 will cancel the x squared, and x squared will also go. Then the next step is for me to factorize out the h. I'll be left with 2x plus h over h. So this cancels, and then the last step is for me to replace h with a 0, meaning that our answer is just a 2x. And then they want us to get the derivative of this, so which means 2 times 3, that's going to be 6x minus 4. That's the answer. And then they want us to find the first derivative of this. Oh, okay. So negative 2 root x, open brackets, we have x minus 1 squared. Okay. So one thing we know that square root of x is the same as x to the exponent over half. We need to open this up using the FOIL x squared minus 2x plus 1. Then I need to open this further. Okay. So what is this going to give me? It's going to give me negative 2x. That's going to be 5 over negative and negative. That's going to be a 4x over 2. It's supposed to be a minus, not a plus. Okay, so we're saying minus 2x to the exponent over half. So this is like the simplified format. Now we need to derive this. So we're going to end up with a negative 5x. Okay, when we subtract the 1 there, that's going to be a 3 over 2. This times that, we're going to have 3 times 2, which is like a 6. X, you subtract 1, have a half. Then this multiplied by that, we're going to be just left with a 1 to the exponent of negative a half. So this becomes the final answer that the question wanted. 8.3, they're telling us, given that y is given as that, is a common tangent to this and then that. Calculate the values of a and b. So one thing that we know about common tangents is that the graphs will be equal at that same point. So what I'm going to do, I'll start by getting this equation and then equating it to this equation so that I solve the value of x at which the 2 points or at which the graphs are the same. So I'll say that my 2x squared minus 4x minus 6 should be equal to 4x minus 14. Okay. Collect the like terms or create the standard equation. So 2x, this becomes negative 8x. And then that becomes a plus 8 is equal to 0. Divide through by 2. X squared minus 4x plus 4 is 0. Factor this out. We have x minus 2 and then x minus 2. Meaning that the graphs are meeting at a point when x is what? When x is a 2. When I substitute this into this graph, meaning that my y value is going to be 4 times 2, which is 8, minus 14, which is a negative 6. So the point of intersection is 2 and negative 6. Okay. And then let me go down to this graph of G. At the point of meeting, the gradient of this graph should be the same as the gradient of this. Okay. And of which the gradient here is a 4. Meaning that let's get the first derivative here and then we equate it to 4, first of all. So I'll say my first derivative is going to be 2ax plus bx plus 18. Now, if x is a 2, I'm going to equate this to a 4, meaning that I have 4a plus 2b plus 18 should be equivalent to the gradient, which is 4. Let's move the 18 that side, meaning that 4a plus 2b gives us negative 14. I don't know if that makes sense. Will that make sense? 4a to b is a 14. No, that doesn't make sense. Why are we having the 18 here? Because we we derive, so that must die. It doesn't make sense. Let's just repeat the entire thing. So it's saying 2 ax plus bx, okay, must give us a 4. When x is a 2, then we're going to have a 4a plus a 2b gives us a 4 divided through by 2. So 2a plus b gives us a 2, meaning that b is going to be 2 minus 2a. Okay, so if that is true, I can have this as my first equation, and then I'll substitute 2 into here, and then I'll replace y with a negative 6. So negative 6 is equivalent to 2 squared, which is 4a, plus 2 times b, which is a 2b, and then plus 18. Is this a plus 18 or a minus? It's a minus 18. Okay, let's move this to that side. We're going to have a 14. So 4a plus 2b is the 14. Dividing through by 2, 2a plus b gives us, is it a 7? 4a plus 2b is giving me a 7. How is it a 7? Is my mind working correct? And how are we getting even the 14? Yes. So what is 18 minus 6? It's a 12, man. When you divide by 2, you get a 6. So if b is going to be 6 minus 2a, is it going to make sense? Is it going to make sense? It's not making sense. B is 6 minus 2a. Something that I'm missing out. I'll keep this equation here. And then I'll go back to the one where I got the derivative. It's here. Why are we keeping this x? Because it's supposed to be something like this. Sorry about that, because when you find the derivative, the x dies out. Okay, so meaning that b is going to be 4 minus 4a. Is that okay? Let's try to simplify this. So 4 minus 4a is equal to 6 minus 2a. Let me move this that side. I move this one that side. So negative 2 is equivalent to 2a, meaning that our a is negative 1. Then I'll get this negative 1 and substitute it there. So b is going to be 6 minus 2 is negative 1, meaning that our b is going to be 8. Yeah, sorry about that, guys. So get the derivative of this correctly, it has to be this, and then equate to the gradient. That's equation 1. This is equation 2. Yeah, it came out. All right, question number 9. They want us to show that k is 1 if we are given this. So step number 1, we just need to open this up. I don't know how you would do it, but I opened the right-hand side up. So I would have something like x minus 4 into x minus k squared. So x minus 4, when I open this, I'll have x squared minus 2xk plus k squared. When I open this up further, okay, I'm going to have something like x cubed minus 2x squared k, and then this and that is going to be plus k squared x minus 4x squared plus 8xk, then minus 4k squared. Then I can collect the like terms, okay, whereby I'm interested in the x's. So this and this will be together, this and this will be together, and then this one will represent the constants, okay, and of which in this case our constant is negative 4. So I would say negative 4 is the same as negative 4k squared. I'll divide both sides by negative 4, which means k squared is 1, and then I'll find the square root, which means k is what? K is 1. There are other alternatives of how to do that. You can factor this out. factorize this left-hand side and then do the equations equating, whereby the k will come out automatically from this side. All right, then 9.2, they want the coordinates of the turning points. So for the turning points, we need to find the first derivative of f. So that's going to be 3x squared minus 12x plus 9. We equate this to 0. When you divide through by 3, you have x squared minus 4x plus 3 is equal to 0. Meaning you have x minus 3, x minus 1 is equal to 0. Turning points are going to be x1 or x3. But then that is not the answer because we want the coordinates. So we need to substitute these ones back into the original equation. Okay, so let me just create some space here. So we're saying if our f is a 1, okay, we're going to get a value of 0 as our y. Okay, and then if we're looking for f of 3, if our x is a 3, what value are we getting for y? We're ending up with a negative 4, meaning that we have 1 and 0, and then we have 3 and negative as our coordinates. All right, then describe the concavity at this point, x negative 3. So we need to find the second derivative. So 3x squared minus 12x, 3x squared minus 12x plus 9. This was the first derivative. Let's get the second derivative, which is going to be like 6x squared minus 12. If I equate this to 0, okay, and then try to solve that. So meaning that, wait a minute, what are we doing wrong? It's supposed to be just 6x minus 12, okay? If I equate that to 0, meaning that my point of concavity must be 2, okay? So for all values that are less than 2, the graph is going to be concave down, okay? But now the question gave us a point of negative 3. So meaning 3 is on the left, it's less than 2. So the concavity is like it's concave downwards. It's concave down. And that's what the question wanted. Then draw the graph, label all the turning points and all of that. Okay, so from what we have, we know that we have x minus 4 and x minus 1 squared. So x minus 4 and then x minus 1 squared, meaning that this bracket is a turning point, but it is also an intercept because we have x as a 4, x as a 1, and then x as a 1 being the intercepts. Okay, so I'll have my x-axis there. Then I could have this as my y. So the intercepts, we have a 4 and a 1. So this is a 1, it is a 4. We got our turning points to be 1 and 0, and then 3 and negative 4. So 3 is somewhere here. Negative 4 is down. Okay, so from the graph, we know that the y-intercept is a negative 4. Okay, meaning that this negative 4 should be the y-intercept also. So since the a is greater than 0, meaning our graph is going to be something of the sort. So I'll have something like this, passing there, and passing through it. So these are the points of interest that the question needed. That is the kind of graph we would have for that question. And then 9.5, they want us to calculate the maximum distance between f and h for this interval. If h of x is the first derivative twice. Okay, so what I'm going to do, I will get negative 2 multiplied by our first derivative, which was 3x squared minus 12x plus 9. So this gives me negative 6x squared plus 24x minus 18. I'm going to get the cubic function, this one, and then subtract it with this one. So if I have x cubed minus 6x squared plus 9x minus 4, now I'm subtracting the whole of this, which is negative 6x squared plus 24x minus 18, because that is going to be like the distance. So x cubed minus 6x squared plus 9x minus 4 plus 6x squared minus 24x plus 18. So this 6x squared cancels that, meaning that I'm going to be left with x cubed. This and that is negative 15x. This and that is going to give me a positive 14 is equal to 0. Then for me to look for the maximum distance, I need to find the derivative, which is going to be like 3x squared minus 15. I'll equate that to 0. Okay, 3x squared, 15 is 0. Then our x squared is going to be 5 when I move it in that side and divide both sides by 3. And then I'll have to find the square root of 5, and we know square root is always plus or minus 5. So my focus is going to be the root of 5, which is between 1 and 3. Since the question is asking for the distance or the maximum distance, I'll get this root 5 and substitute it into this distance formula of ours. So it's going to be root 5 cubed minus 15 times root 5 and then plus 14. If that happens, I'm ending up with 38,36 units as my answer. Okay, then question number 10, we're almost there. They're telling us that if A and B are mutually exclusive, this simply means that the probability of A and B is 0. There is no intersection there. So they want us to get B. So for us to get B, we shall get the probability of A or B, which is 0.79 minus the 0.42, which gives us 0.37. 10.2, a game at a fun park requires a player to roll a 6-sided die and pick a card for 52. A player to win will get odd numbers. So odd numbers are 1, 3, and 5. Appears on the face, and then the die must also be a picture card. So how many picture cards do we have? We have a jack, they told us, a king, a queen, and then the ace. So this is 4 by 4, meaning that we have 16 cards. So let's get, before we even read what is happening down here, what is the probability of winning? So you must get 3 out of 6 for the die times 16 over 52 for the cards. So simplifying that, I'm getting 2 over 13. This is the probability of winning. Okay. Then they're telling us that a player pays 10 rands to play the game, and in an hour, 260 people can each play. If the owner wants 70% profit payout, I get the maximum amount that the owner must pay out to each win. So it's more like a lotto, whereby if you win, if people win, they must share the amount that was won. Okay, so if this is the percentage of winning, how many people can win out of the 260? So we're going to say that 260 times 2 over 13. Okay, so this times 260, I'm getting 40 people. So in any 1 hour, only 40 people can win. Then if 10 people, the 260 people are contributing 10 rands, which means we can collect a maximum of 2.6. And then the profit, which is 70%, 70 over 100 multiplied by 2.6. Okay, so 2.6 times 70% gives me 1,820. This is now for the owner, okay, for the big boss. Now we need to get whatever needs to be shared. So we shall get the 2.6, we subtract the 1820. Okay, so we subtract 2.6, which means that only 708 rands must be shared amongst the winners, okay? So meaning that each winner is going to get 780 divided by 40. Okay, so 780 divided by 40, which means you can only get 19 rands and 50 cents. That's if you win, okay? So chances are high you may not even win anyway. So that is what the question is asking for. Calculate the maximum amount the owner must pay out to each winner. So that is 1950 cents. So that is how the 6 marks would have been approached. Okay, get the probability of winning, and then you take it from there. Lastly, question 11, consider three-digit numbers 501 up to 999. How many of these three-digit numbers have exactly 15 in them? So since there are 3 digits, we have like 3 scenarios. First scenario is where the 5 comes first. Okay, so if the 5 comes first, which means we only have 9 digits to choose from for the second and then the third, because those ones can repeat. Okay, so that's going to be like 1 times 9 times 9, which is 81 chances. Okay, or options. Then what if the 5 is in between, meaning that the number that comes here can the number that comes first can be 6, 7, 8, and then 9. So we have 4 numbers to choose from for the first one. So that's a 4. The second one is fixed, which is a 5. And then the third one can be any number, which is a 9. So this gives us a 36. Then what if the last digit is a 5? Okay, it's fixed as a 5. So for the first digit, remember numbers between 501 and upwards. So still 6, 7, 8, and then 9. So those are 4 times 9 numbers, and then times 1, which is 36. So how many of these numbers? We're going to get 81, 36, and 36. So 81 plus 36 plus another 36. Okay, that gives us 153 numbers. Okay, then 11.2, calculate the probability of the 3-digit numbers not satisfied. Now the question is, how many 3-digit numbers can we obtain from this sort of arrangement? So if I get 999 minus 501 plus 1, okay, so 999 minus 501, and then I plus a 1, which means we have 499 combinations or numbers that we can come up with. But then it's 153 that can satisfy our desired condition. So let's subtract 153. Okay, if you subtract 153, we're going to be left with 346. Now the probability of not satisfying, okay, it's going to be 346 over the possible 499. So 346 divided by 499, we end up with 0.693, and so on and so forth. So that should be the probability that the question wanted. So guys, that brings us to the end of the paper. Please remember, this is the proposed memorandum and not the actual memorandum. Okay, so if in any case there are any hiccups, any errors, please, we apologize, and we appreciate your positive feedback and constructive criticism. So wish you all the best in your paper too. Let's meet then. Bye-bye for now.